Hello, this is Andrew. In our last videos, we started looking at the initial configurations that you do on a switch as you first take it out of the box. So in this next couple of videos, we're going to start looking at why do you even need a switch. So in order to do that, we're going to take a little, we're going to build up to a switch, and this information is kind of foundational into understanding VLANs and to understanding how switching works on the LAN in general. So this is important topics here. So, and of course, it's all going to be on CCNA or ICND1 exam. So we're going to go through this, and if you have difficulty, go ahead and watch it again. Some of this might be difficult. I try to make it as clear as possible. But okay, what is a switch? Why do we have a switch? Well, let's say, for example, our goal is we want to connect these PCs such that they can transfer email or FTP files to each other, whatever it is they want to do. So let's take this PC down here. He sends an email, and it's a 5-volt message going across this metal plate. Okay, it hits the plate, and bam, it goes out to every PC that's attached to this metal plate. So everything within this circle received this transmission. That's one broadcast domain. Everything that received this is a broadcast domain. Everything that received the transmission from this PC is in one broadcast domain. Okay? Well, that's pretty good, but what happens if this PC and this PC transmit at the exact same time such that they both land here, and now it's 10 volts? Now, there's potential on this plate, and at every PC is 10 volts, so that the message is corrupted. It's not usable. Okay? So even worse is every PC could transmit at the same time. And this is going to be 10 volts plus something. This is going to be plus 10 volts plus something else. So it could be 15, 20, who knows? And so all of these make one collision domain, because that means it's possible for this one to collide with this one, with this one, with this one, with this one. They all live in one collision domain. And they also live in one broadcast domain. Okay? So, well, now let's just replace that metal plate with a hub. And a hub is somewhat different than a metal plate, of course. It's more sophisticated. It has some, it has some repeater capabilities where it takes the signal, repeats the signal such that you can transmit over a longer distance. But functionality, as far as we're concerned, a hub is really no different than a metal plate. It's one broadcast domain, one collision domain. That means if I transmit here, and this guy transmit here at the same time, then we have a collision. The data is corrupted. It's unusable. Okay? If I transmit here, and nobody else is transmitted, everybody in this circle, in this broadcast domain, gets that transmission. So a hub, from a functional standpoint, as far as we're concerned, is not much different than a metal plate. Okay? And that's just clearly not going to work. So we have to find some kind of solution. So in comes CCNA CD. This is carrier sense multiple access with collision detection. And this will be on the exam, and additionally, this somewhat similar algorithm is still used with wireless transmissions, but as far as actually using these anymore, CCNA I don't think is used anymore. Okay? If you look at different books or different, the problem with doing this presentation is that ICND1 is very simplistic in many ways. You get a lot of information, but you're not going into any detail. You could probably write, there's probably 20-page papers written on how the collision carrier sense multiple access with collision detection works, but you don't need that for the exam, and you don't need that for this material. But so if you looked up CSMACD, you would see a few different examples of the algorithm. And I'm not going to read these to you. I like the looks of this one. It's okay. The PC looks to see if someone else is on in the broadcast domain. If so, he holds off. If not, then he's free to transmit. If the transmission is uncorrupted as he checks the line, then there was no collision. But if the message was corrupted, then a collision occurred. So we would wait a random amount of time and try again. Okay, so here's our collision domain hub. And I'm actually going to stop the video here and pick it up in the next video. Thank you.